It's going to be similar to the first one I did, but it will be different in that we're going to look at the effects of dosage and of potentially having more than one antibody present and what we do with that situation. Okay, so patient B here had an antibody screen done, and that is right here, the results of that. And this is tube testing that we're looking at, and we can see that for vial 1 it was completely negative, and then vial 2 the antibody, or there was a reaction at the AHG phase. And because the screen was positive, then of course we're going to go ahead and do the antibody identification panel to see if we can identify what's present in the patient's plasma. Okay, so the first thing I like to do, as usual, is just kind of have a look generally at what's going on here. So the first thing is we'll look at the patient cells or the auto control, and we can see here we have 0, 0, 0 at initial spin, 37 degrees, and the AHG, or otherwise known as the anti-human globulin phase. And then the last one is the check. That's the check cells telling us that the AHG test was carried out correctly. So that's good. That's a good way to start out a panel, because if your auto control or your patient cells, which by the way is a combination of patient red blood cells and patient plasma, if that is positive, that pretty much invalidates your panel, because you don't know if any reactions up here are from an allo antibody or from the auto antibody. And remember, auto antibody means an antibody to oneself, and allo antibody is an antibody to a foreign antigen. Okay, so that looks good. We can see in our reactions here that we have no reactions at initial spin, no reactions at 37 degrees, and then we have all of our positive reactions at the AHG phase. So as we recall, initial spin is generally where we tend to see IgM or cold or room temperature antibodies, so it doesn't look like we're dealing with any of those. And it looks like we're probably going to be dealing with IgG, because the IgG tends to react at 37 and more specifically at the AHG phase. So we have 2+, 3+, 2+, and 2+. So why do we have differing strengths? So there are a couple reasons why we can find ourselves in this situation. One is because of the effect of dosage, that if we have a homozygous antigen expression, it's going to be stronger. Maybe it's going to show a 3+, and if we have heterozygous, it will be weaker, and it's a 2+. Or we may be looking at a situation where there's more than one antibody present. Okay, so the first thing I'm going to do here is I'm going to circle all of my positive vials or cells. So we have 1, 3, 6, and then TC, which stands for technical cells, and we're just going to treat that as the 11th vial, or sometimes I'll refer to it as these as cells. So the TC cell. Okay, so as we did in my first video, we're going to go ahead and start ruling out, and we don't. It would seem logical that we'd go to the positive ones and rule out the negative ones, but what we're going to do is we're going to go to the negative cells, the ones that have no reactions whatsoever, and we're going to rule out the positives here. So let's start here. Okay, so D, which is all by itself, I'm going to go ahead and completely rule that out by giving it a cross or an X. All right, now let's talk a little bit about dosage. So here we have big C and little c, and these are a pair. Therefore, we're going to take dosage into consideration. Just as I said in my first video, that we are going to take a little more conservative approach, that anytime we have a pair like big C, little c, Duffy A, Duffy B, Lutheran A, Lutheran B, we're going to take dosage into consideration. But generally speaking, dosage is probably most pertinent to big C, little c, big E, little e, Duffy A, Duffy B, A, Kid B, big M, big N, and big S and little s. The rest of them, even though there are pairs, aren't in blood banking, sometimes it's just not really, we don't apply a dosage to them. But in my laboratory, we're going to take a little bit more conservative approach, and anytime we have a pair, we're going to take dosage into consideration. Okay, so big C here is homozygous, meaning that it's by itself, meaning that that antigen is going to show a strong expression. And since there's no reaction over here, it's completely negative, we can pretty confidently say that that big C is not there. So it's a homozygous rule out, so I'm going to give it an X. Okay, big E, little e. Okay, little e is homozygous, let's cross it out. Okay, now CW here, it's by itself, so since there's no competition with it being homozygous or heterozygous, I'm just simply going to completely rule it out with an X. Okay, big K and little k. So Kel, those are both heterozygous, so I'm going to give them just a slash like that. We'll come back to those. Okay, KPB, homozygous. JSB, homozygous. Duffy A, heterozygous. Duffy B, heterozygous. Kid A, heterozygous. Kid B, heterozygous. Lewis A, homozygous, so it gets an X or a cross. P1, we're going to completely rule that out. M, heterozygous. N, heterozygous. Small s, homozygous, so it's going to be completely eliminated. Lutheran B, homozygous, completely eliminated. All right, let's go down to number 4. Okay, now we have little c, homozygous. Let's rule it out. V, it's by itself. We're going to rule that out. Okay, small k, it's homozygous, so we're going to rule that out. Okay, Lewis B, homozygous. Okay, now we have big M, homozygous, so now we can rule that out. Okay, now big S is heterozygous, so let's give it 1 slash. And XG here is by itself. Let's go ahead and rule that out. Okay. Okay, Duffy B, homozygous. Okay, big S, homozygous. Let's go to 7. Okay, Kid B, homozygous. Oh, man. Big N, homozygous. Okay, Duffy A, homozygous. Okay, Lutheran A is heterozygous, so we'll give that just a forward slash. Okay, Kid A is homozygous. Let's get rid of that. Okay, all right, we've gone through everything. All right, now what I like to do is I like to go and take a red pen and circle the things that we have left. Okay, so we have big E, we've got Kel, we've got KPA, we've got JSA, and we've got Lutheran A. So these are the ones that are not double crossed out, that don't have an X through them. Either they were not ruled out at all or they were heterozygous. All right, let's go ahead and talk about these and see if we can get rid of some of these. Okay, so let's talk about low incident antigens. So here we can see KPA, it's absolutely 0. There are no positives here. So the way, one way of looking at low incident antigens is that they tend to be ruled out because, for example, you would do something with them if, for example, you did a cross match and if you determine that the patient had an antibody, and then you got units that were negative for that antibody, so you knew there shouldn't be any reaction, but then you did the cross match and there was a reaction. Then you'd probably have to go back and take a look at your low incident antigens and see if those are what are causing the positive cross match. But since it's completely zero here, I'm going to go ahead and let that one go. I'm going to cross it out. Okay, JSA. All right, so this also is low incident, but we have a problem here is because it's positive in one of the cells that's positive, and therefore we can't rule it out just yet. Okay, so let's see, Lutheran A. All right, so Lutheran A, also again low incident antigen. Now it happens to be positive here in a completely negative. These are all negative reactions. Now when it comes to ruling out a cell or an antigen like this, it's better to have more than one heterozygous rule out. So if we had another one, like in cell 4, if this were positive, I'd be much more confident to rule this one out. So one thing that you could do is you could get another cell from another panel from a different lot number, and you're going to try to find one that is going to allow you to have two rule outs. Let's see, we could take a look at the antibody screen here, and okay, this doesn't really help because it's negative for Lutheran A in both of these. We're going to need one that's positive, but that comes up with negative reactions. But that being said, I'm going to go ahead and rule it out and consider it, because it's not, unlike JSA, which is positive here for a cell that is positive, this is not. It's negative here. So once again, if there's a problem, if I come back and if I go and do a cross match and there's a problem, this is one of the ones that I may have to go back and look at. But depending on the lab you're in, you may be required to go ahead and get another cell and rule that one out. Okay, let's go back to Kel here. So now what I was talking before about having two negative cells, here we have heterozygous, and that's negative, and we have another heterozygous that's completely negative. So that gives me a little bit more confidence that I can probably rule this one out. Now that being said, two heterozygous do not equal a homozygous, but I'm just interpreting what I see here, and for me, I am pretty confident that this is not big K. All right, so that leaves us with big E and JSA. So let's see if that fits. So big E is positive in 1, 1, 3, 3, 6, 6, TC, TC. Okay, so I feel pretty good here about the pattern that I see, and besides that, big E is an IgG antibody, and all of our reactions are taking place at the AHG phase, which is suggesting that this is an IgG antibody. All right, now let's see if we can answer the question about why we have different reaction strengths. So big E, okay, so that's heterozygous, so we have 2+. Okay, now here we have homozygous, and we have a 3+, so that kind of makes sense because big E is homozygous, therefore it's going to have a stronger expression in this cell, and that's why we have a 3+. Okay, in cell 6 we have heterozygous, so once again we have 2+, and then in TC we also have heterozygous and we have 2+. So that matches, I mean that makes sense as far as dosage goes. The only cell that's homozygous is showing a stronger reaction. Okay, so let's, what are we going to do here with JSA? So what we're going to need to do, because as I said before, it's positive for a cell that's positive. So we don't know if this is being masked by the big E. So what we're going to have to do is we're going to have to go to a different lot number of a panel cell. You can't use the same one, because you're just going to be using the same cells. So you have to go to a new lot number, and you're going to have to find a cell that is not, see this one is positive for big E and positive for JSA. So what you're going to have to do is you're going to have to find a cell that's negative for big E and positive for JSA. And then if you run that cell and it's negative, then that's going to tell you that it's probably not JSA. Now I did say something about having two cells as far as being heterozygous and ruling out. So your laboratory may require you to get two cells to rule that out. But for us, we're just gonna. At this point, that is what I would do. And let's just make the assumption that I did that testing and it came back negative. So that is going to allow me to rule that guy out. All right, so that leaves us just with big E. So now we have to fulfill the rule of three. And the rule of three states that for any antibody, it has to be positive in 3 cells and negative in 3 cells. So we have 1, 2, 3, and there are no other antibodies taken into consideration here, meaning that we're not really worrying about more than one antibody being present. We've pretty much ruled everything else out. And then we have -1, -2, -3. So our rule of three has been met. So we can say with confidence that the antibody we're dealing with here is anti-drug.